So, hello. In the previous class, I told you that in the vector synopsis, a little bit is left off so that after that, we can go to the questions, multiple choice questions. And the left off part is if there is a straight line which is passing through a point A and parallel to vector B, then the vector equations we will find here vector equations. So vector equation of this straight line would be r equal to a plus k into b, vector a into vector b. Now if a straight line is passing through 2 points a and b whose position vector is a and b, in such case the vector equation would be r equal to vector a plus k into b minus a. If you want to find the perpendicular distance from a point B whose position vector is r from a line passing through the point A whose position vector is A and parallel to B and C vectors. So I will draw this in the next page. We are finding perpendicular distance from a point P whose position vector is R from a plane. So we are finding this perpendicular distance. This plane is passing through the point A whose position vector is A, and this plane is parallel to vector B and vector C. In such case, the perpendicular distance PM is given as magnitude of R minus A dot B cross C by magnitude of B cross C. In the same way, if there is a point P whose position vector is R, and if there is a plane, the perpendicular distance from this point to the plane, which is passing through 3 points A, B, and C, whose position vectors are A, B, and C, is PM equal to magnitude of R minus A dot B cross C plus C cross A plus A cross B by magnitude of B cross C plus C cross A plus A cross B. So these all are about double vectors. But now we will be dealing with triple vectors. So we will be learning scalar triple product of 3 vectors. It is given as A cross B dot C. And in short, it is represented as vector A, vector B, vector C in a box. It is called box ABC, which is also equal to box BCA, which is also equal to box CAB. So actually the scalar triple product, in short, we are writing as or representing it as a box. But this box, if written in a particular order, it is one at the same. can be treated as equal, but the order should be maintained in a particular way. Okay. So regarding the scalar triple product, A cross B dot C is same as A dot B cross C. And box ABC is minus box BAC if the order is changed. If vector A is given as A1I plus A2J plus A3K, vector B as B1I plus B2J plus B3K. Vector C as C1I plus C2J plus C3K. Then box ABC can be found in an easy way by finding the determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Next page. If box ABC is 0, then I can say that any two of the three vectors, ABC are collinear or equal. Then only the box will be 0. Otherwise, if box ABC is 0, I can also say vector ABC are coplanar. In either of the ways, I can say this. We can say that ABC are in a right-handed system or left-handed system accordingly if box ABC is positive or negative. Then if you have a tetrahedron like this with A, B, C, D vertices, then the volume of the tetrahedron is 1/6 into magnitude of AB cross AC dot AD. The next formula is box ABC into box UVW is determinant of A dot U, B dot U, C dot U. A dot V, B dot V, C dot V. A dot W, B dot W, C dot W. Now, if there are 4 points A with position vector A, B with position vector B, C with position vector C, D with position vector D, will be coplanar if box ABC plus box DCA plus box DAB equal to box ABC. Here box DBC. So box DBC plus box DCA plus box DAB must be equal to box ABC. So these are a few things which you have to learn. And some more points I will be telling you in the next page. If vector P is x1a plus x2b plus x3c, vector Q is y1a plus y2b plus y2c, vector R is z1a plus z2b plus z3c, then box PQR can be written as determinant of x1, x2, x3, y1, y2, y3, z1, z2, z3 into box ABC. Next, we will take equation of plane in a few cases. That is, suppose there is a plane. The plane is passing through a point whose position vector is A, and parallel to the plane which contains vector B and vector C. Equation of such plane will be box R minus A, B, C equal to 0. Similarly, if there is a plane passing through 3 points A, B, C, whose position vectors are A, B, and C, equation of such plane will be R is equal to 1 minus lambda minus mu into A plus lambda into B plus mu into C. Or in short, you can write R dot B cross C plus C cross A plus A cross B equal to box ABC. Either of the ways. The next is, if there is a plane which is at a distance P from the origin. Suppose this is the origin. The distance is P from the origin. And having a unit normal vector. So this plane is having a unit normal vector n. Then equation of the plane will be R dot n is equal to P. Similarly, if there is a plane which is passing through the point A, whose position vector is A, and it has a unit normal vector n, then its equation will be R minus A dot n is equal to 0. Next, from origin, a perpendicular is drawn to a plane. And the plane is passing through the points A, B, and C with position vectors A, B, and C. Then the length of this perpendicular OP is box ABC, magnitude of it or absolute value of it by magnitude of B cross C plus C cross A plus A cross B. Now, we will deal with vector product of 3 vectors or vector triple product. Like scalar triple product, we have vector triple product for 3 vectors. That is A cross B cross C. So, A cross, one second, I will erase this. So now A cross B cross C you can find by taking A dot C into B minus A dot B into C. Again, A cross B cross C can be found by taking A dot C into B minus B dot C into A. So clearly we can see that A cross B cross C is not equal to A cross B cross C in general. But if A cross B cross C, you find it equal to A cross B cross C, this happens only if A, B, C are collinear. Only in this one case, you can see this is happening. So I think these synopsis things are enough. There are more, but while dealing with the problems, we will learn these all things. And there are many shortcut methods also. So wherever shortcut methods are needed during multiple choice questions, we will learn this. So let us start with the first problem. The vector C is directed along the internal bisector of the angle between the vectors that is A equal to 7i minus 4j minus 4k and B equal to minus 2i minus j plus 2k with magnitude of vector C as 5 root 6 is, so the required vector C is on the internal bisector of the angle between the vectors A and B. So this is vector A, this is vector B. And the internal bisector is this internal angle bisector. So the vector C is along this. In such case, you can find the vector C by taking lambda into A by magnitude of A plus B by magnitude of B. See, some formulas like this, I'm doing the problems and telling you. Because if we go on taking the formulas, one thing is there are many formulas. And the other thing is you will get bored just seeing the formulas if you don't use it in the problems. That is why. Okay, so we will find A by magnitude of A. And that is 7i minus 4j minus 4k by square root of 49 plus 16 plus 16. And that is 7i minus 4j minus 4k by square root of 81. And that is 7i minus 4j minus 4k by 9. Similarly, we will find B by magnitude of B. That is minus 2i minus j plus 2k by square root of 4 plus 1 plus 4. That is minus 2i minus j plus 2k by square root of 9, which is 3. So now we have c equal to lambda into I can add up both. So I will have 7i minus 4j minus 4k minus, I have to multiply this by 3. The second one I have to multiply by 3. So that common denominator. Okay. So I have minus 6i minus 3j plus 6k. And then denominator is 9. So this is lambda into I minus 4j minus 3j minus 7j minus 4k plus 6k. That is 2k by 9. Now, we know that magnitude of vector c square will be lambda square into 1 by 81 plus 49 by 81 plus 4 by 81, which is nothing but 54 lambda square by 81. But magnitude of C is already given to us. 5 root 6 whole square equal to 54 lambda square by 81. 25 into 6 equal to 54 lambda square by 81. Lambda square will be 25 into 6 into 81 by 54. 6 ones, 6 nines, and 9 nines. So lambda will be 5 into 3. That is lambda will be 15. And so you can write C vector. The C vector will be, actually you can take plus or minus. So C vector will be plus or minus 15 by 9 into I minus 7j plus 2k. Therefore, option A comes to be true. Next, we will go to example 2 or question 2. In question 2, vector A is given as 2i plus j minus 2k. Vector B is given as I plus j. There is a vector C such that A dot C equal to magnitude of vector C and C minus A is equal to 2 root 2. And angle between A cross B and C is 30 degrees. Then you have to find magnitude of A cross B cross C. That's the question. So it's looking complicated, isn't it? But if you see the answer, it is very simple. So first thing is we can find what is A cross B. It is IJK 2 1 minus 2 1 1 0. That means I is multiplied with 0 plus 2. Minus j is multiplied with 0 plus 2. And k is multiplied with 2 minus 1. That is 1. Actually, I have to go on writing this cap. Sometimes I may not write. So don't get confused. Minus j is multiplied with plus 2. So what we will have, 0 minus of minus 2. Okay. Then we will see magnitude of A cross B. It is square root of 4 plus 4 plus 1. That is square root of 9. That is 3. Now, magnitude of C minus A whole square will be 2 root 2 whole square. That is 4 into 2, 8. So I can write magnitude of C square plus magnitude of A square minus 2 times A dot C is equal to 8. Or magnitude of C square plus magnitude of A square, A dot C is given as magnitude of C. So 2 times magnitude of C is equal to 8. Then magnitude of C square, magnitude of A square, because we can see magnitude of A from the question. Magnitude of A is square root of 4 plus 1 plus 4, square root of 9, that is 3. So magnitude of A square will be 9 minus 2 into magnitude of C is equal to 8. Or I can write magnitude of C square minus 2 into magnitude of C plus 1 is equal to 0. That means magnitude of C minus 1, magnitude of C minus 1 whole square equal to 0, or magnitude of C is equal to 1. Now, because I have to find magnitude of A cross B cross C, it will be equal to magnitude of A cross B cross magnitude of C. Sine angle between A cross B and C, that is 30 degrees, which is given. Magnitude of A cross B, we got 3. Magnitude of C, we got 1. Sine 30 degrees is 1 by 2. So the answer is 3 by 2. Isn't it simple? It's looking difficult, but once we find all, it will be very easy. Now the third question is, vector A, B, C are non-coplanar vectors. Then the points which I'm telling you here, that is A minus 2B plus 3C, 2A plus 3B minus 4C, minus 7B plus 10C are, there are options. Are they collinear? Are they vertices of a triangle? Are they vertices of right angled triangle, or none? That is what you have to find. So let us take the given points as A, B, C and O. That means A we will take A minus 2B plus 3C. B we will take 2A plus 3B minus 4C. And C we will take minus 7B plus 10C. Let O be the origin. So we know that AB vector can be written as OB vector minus OA vector. So OB vector. OB vector is 2A plus 3B minus 4C minus OA vector is A minus 2B plus 3C. So we get A plus 5B minus 7C. Similarly, we can find AC vector by taking OC vector minus OA vector. OC vector is minus 7B plus 10C minus OA vector is A minus 2B plus 3C, which will give us minus A minus 5B plus 7C. These subtractions you know very well. But if you see AB vector and AC vector, aren't they looking similar? This is AB vector, this is AC vector. They are similar with a slight difference. So what I can say is AC vector is minus of AB vector. Since A is common in both of them, we can say A, B, C are collinear vectors. Let's go to the next question. Fourth question. You have to find the unit vector perpendicular to both I plus j and j plus k. That is the question. So the unit vector perpendicular to both will be A cross B by mod of A cross B. That is the formula. So this we will take as A and this we will take as B. That means we have to find I plus j cross j plus k and denominator mod of I plus j, magnitude of I plus j cross j plus k. So first of all, I will find what is I plus j cross j plus k. How to find? Take the determinant I, j, k. Then 1, 1, 0. Then 0, 1, 1. I have to take. So I is multiplied by 1. Minus j is multiplied by 1. Then k is also multiplied by 1. And the mod of I plus j cross j plus k also I will find. Square root of 1 plus 1 plus 1. That is square root of 3. So here I can write I minus j plus k by square root of 3. This is how I will get the answer. Next, question 5. If A cross B whole square plus A dot B whole square is equal to 144 and magnitude of A is 4, then magnitude of B you have to find. There is one formula. I told you some formulas I will tell you while doing the questions. A cross B whole square plus A dot B whole square is A square B square. This formula we will use. So this is 144 equal to A square is nothing but magnitude of A square and B square is nothing but magnitude of B square. So 144 is equal to 4 into magnitude of B square, or magnitude of B square is 144 by 4. So magnitude of B will be 12 by 2. That is 6. Sorry, one mistake I made here. I did not square it, and that's why I'm not getting the options. What I mean is magnitude of A square is 16 into magnitude of B square. So magnitude of B square is 144 by 16, or magnitude of B is 12 by 4. That means magnitude of B will be 3. That is only the small mistake. You can correct it. Let us go to question number 6. If magnitude of A plus B is equal to magnitude of A minus B, then angle between A and B is, okay, so take the given information and square both the sides. Magnitude of A plus B square equal to magnitude of A minus B square, or A plus B square equal to A minus B square, or A square plus 2 times A dot B plus B square equal to A square minus 2 times A dot B plus B square. You can cancel A square, you can cancel B square. 4 times A dot B equal to 0, or A dot B equal to 0. That means A and B are perpendicular to each other. That means A is perpendicular to B. So you can say angle between A and B is 90 degrees, which they are asking for. Next is question number 7. If A is a unit vector, A is perpendicular to B, and A plus 3B dot 2A minus B equal to minus 10, then magnitude of B you have to find. So using the information which is given, we will try to get the answer. First of all, A plus 3B dot 2A minus B is given as minus 10. So expand it. 2 into A dot A minus A dot B plus 6 into A dot B minus 3 into B dot B equal to minus 10. Now, always you have to remember that the given information, as A is perpendicular to B, you can say A dot B will be 0. So 2 into A square minus 0 plus 0 minus 3 into B square equal to minus 10. 2 into mod magnitude of vector A square minus 3 into magnitude of vector B square equal to minus 10. Because A is a unit vector, magnitude of unit vector will be 1. So 2 minus 3 into magnitude of B square equal to minus 10. Minus 3 into magnitude of vector B square is minus 12. Or magnitude of vector B square is 4. That means magnitude of vector B is 2. That's it. Next, we can move on to the next question. That is question number 8. Projection of vector AB on vector CD, where A is 4 minus 3, 2. B is 1 minus 1 minus 1. C is 2, 2, 2. D is 3, 3, 3. Is. So first of all, we have to find a few things which are important. We have to find vector AB. That is B minus A. We have to take B minus A. So that will be 1 minus 4 minus 1 plus 3 minus 1 minus 2, or minus 3, 2 minus 3. Then we have to find vector CD. That is D minus C. For that, 3 minus 2, 3 minus 2, 3 minus 2. That means 1, 1, 1. Now, the formula for projection of vector AB on vector CD is vector AB dot vector CD by magnitude of vector CD. So that means I have to take dot product of minus 3, 2 minus 3 and 1, 1, 1, and magnitude of CD will be square root of 1 plus 1 plus 1. The dot product will give me minus 3 plus 2 minus 3 by square root of 3. And that is minus 4 by square root of 3. If we know the formulas, we can do them very easily. Okay, coming to question number 9. Question number 9 says, if A plus B equal to C, magnitude of A is 4, magnitude of B is 6, magnitude of C is 8. Then we have to find angle between vector A and vector B. That's the question. Because in the question you have some given information, that is vector A plus vector B equal to vector C. We can take A plus B whole square equal to C square, or A square plus 2 times A dot B plus B square equal to C square. That means magnitude of vector A square plus 2 times magnitude of A into magnitude of B, because A dot B definition cos theta plus magnitude of B square equal to magnitude of C square. Now magnitude of A square is 16. 2 into magnitude of A is 4, magnitude of B is 6, cos theta, magnitude of B square is 36, and magnitude of C square is 64. So 8648 cos theta equal to 64 minus 36 minus 16, or cos theta is equal to 64 minus 52 will give me 12 by 48. So cos theta is 1 by 4. Theta will be cos inverse 1 by 4. We are asked to find the angle between A and B, and that we got it as cos inverse 1 by 4. Let us go to question number 10. Or 10 we will skip and we will go to question number 11. I think we can skip all these because these all are easy. Directly we will go to question number 30. The unit vector which is orthogonal to the vector 2i minus j plus 2k and is coplanar with the vectors I plus j minus k and 2i plus j minus k is. There is lot of information given here which we have to extract. So what is said is we have to find the unit vector. So let the unit vector in the beginning, to avoid confusion, we will take xi plus yj plus zk. And so we will have x square plus y square plus z square equal to 1. Now this unit vector xi plus yj plus zk is orthogonal. Orthogonal to 2i minus j plus 2k. That means perpendicular. So if you take dot product of xi plus yj plus zk dot 2i minus j plus 2k, we get 0. That is 2x minus y plus 2z equal to 0. We got one equation. Again, the unit vector xi plus yj plus zk is coplanar with the vectors I plus j minus k and 2i plus j minus k. Coplanar means what? The determinant x, y, z, 1, 1 minus 1, 2, 1 minus 1 is equal to 0. So when I find the determinant, what I will get? X into minus 1 plus 1, that is 0. Minus y into minus 1 plus 2, that is 1. Plus z into 1 minus 2, that is minus 1, which is equal to 0. So I get minus y minus z equal to 0 or y plus z equal to 0. This is equation 2. Now I have one more equation, x square plus y square plus z square equal to 1. That I can take as equation 3. I will write equation 1 again, which was in the previous page. So this is what I got for equation 1. So from equation 2, I can write like z is equal to minus y. And so this equation 1 becomes 2x minus y minus 2y equal to 0, or 2x minus 3y equal to 0, or x equal to 3y by 2. Then y I have minus z, because y is minus z. I can write x equal to minus 3z by 2. Now because x square plus y square plus z square is 1, 9z square by 4 plus z square equal to 1. Or 9z square plus 4z square plus 4z square by 4 equal to 1. Or 17z square equal to 4. Z equal to 2 by square root of 17. Y is minus z. So y will be minus 2 by square root of 17. X is 3y by 2. So x is 3 by 2 into minus 2 by root 17. That is minus 3 by root 17. So the unit vector is xi plus yj plus zk. This is how we get the unit vector. We can do one more problem and end the class. We will take question number 14. Vector A is given as I minus 3j plus 4k. Vector B is given as 6i plus 4j minus 8k. C is given as 5i plus 2j plus 5k. And a vector R is there such that R cross B is equal to C cross B. R minus A is 0. Then vector B mod of vector B by magnitude of vector R minus C is equal to what? We have to find this. So because we are given R cross B is equal to C cross B, I can write A cross R cross B will be equal to A cross C cross B. Or according to vector triple product, A dot B into R minus A dot R into B will be equal to A dot B into C minus A dot C into B. So I can write A dot B into R. I can write A dot R into B. I can write A dot B into C, A dot C into B, all. So first of all, I will write A dot B. It is 6 minus 12 minus 32 into R. minus, because r dot a is 0, this will become 0, is equal to, again a dot b, 6 minus 12 minus 32 into c, minus a dot c, 5 minus 6 plus 20 into b. So 6 minus 12 minus 32, it is minus 38 into r, equal to minus 38 into c, minus 19b. Or if I take 38 common, I will have r minus c equal to 19b. Or magnitude of b by magnitude of r minus c will be equal to 38 by 19, that is 2, which is asked in the question. So almost we have covered all the topics except a few. You can practice on your own and learn the remaining. With this, we will end this class, and next class we will do some more topics, some more new topics we will go to.